LED tubes are designed to replace standard fluorescent tubes inside overhead commercial light fixtures. Unlike traditional incandescent and fluorescent lighting, a light-emitting diode produces light through a microchip. It lasts twice as long and uses less than half the electricity, which is a bright idea. These LED tubes come in various lengths. They're designed as a modern, energy-saving alternative to use in those ubiquitous overhead fluorescent tube light fixtures found in offices, shops, hospitals, and schools. The process begins with a printed circuit board. Printed means the board has a network of conductive copper lines and rectangular pads, designed to electrically link electronic components together. A technician places the circuit board on a track, which ferries it to the first computer-guided machine on the line. The machine covers the board with a metal stencil that has openings matching the locations where the electronic components will be mounted on the board. Then the machine spreads a layer of lead-free tin alloy solder over the stencil. This only applies solder to the board where the components will go. The next computer-guided machine on the line mounts the first of those components, the light-emitting diodes, or LEDs. They're composed of a microchip coated with the chemical phosphor and come in different sizes, colors, and light outputs. The factory programs the machine's chip shooter to pick the required LEDs off supply reels and place them on the solder-coated locations on the circuit board. The chip shooter works at astonishing speed, placing up to 11 LEDs a second. It places each one with absolute precision. But just to make sure, a camera focused on the board verifies that every LED is in exactly the correct position. The circuit board now moves to a third computer-guided machine for the next electronic components, the terminals. The terminals receive the electric current to power the LED light tube. The machine picks one terminal at a time and places it at one end of the circuit board. The circuit board then moves to the final machine on this line, a tunnel oven. The temperature inside peaks at 240 degrees Celsius. The heat melts the solder, fusing the components to the board. Solder is both adhesive and conductive, so this bond also connects the components to the board's copper electrical network. For the high light output tube they're making here, each board is comprised of 8 strips, each of which has dual rows of LEDs. The strips are snapped apart. Each one is 30 centimeters long. The tube length being made requires 4 strips. On the assembly line, 1 strip with the terminal and 3 without are slid into an aluminium track. The technician gives them a thorough visual inspection and then solders the strips to each other. Once soldered, the strips are electrically bridged, so the terminal on the first strip can power all of them. The aluminium track, called a heat sink, is critical to the tube's performance. It has deep fins on the bottom, which dissipate heat, cooling the LEDs. This keeps the color of the light consistent and extends the tube's life. Once the technician has connected the strips, he plugs a power source into the terminal to test the LEDs. Next, he inserts wires into the terminal and locks them in with a compression tool. The opposite ends of the wires connect to the power supply in the light fixture. A transparent polycarbonate lens is snapped into the grooves on the side of the heatsink. The tube is closed up by placing a cap on each end. Each cap's pins are aligned with slots on the press. The press is then activated, which forces the caps into the tube, attaching them permanently. The end with the terminal has slots in it, enabling the wires to protrude. The light tube is finished and ready to be boxed for shipping. To install this energy-efficient LED tube, you simply click the pins on the end caps into receiving slots in the light fixture. Then connect the wires to the power supply and the fixture's wiring. Thanks to the cooling fins on the heatsink, one LED tube lasts for 100,000 hours, and has a guaranteed 10-year lifespan. So for this light, you could say the future's bright. Right, time to indulge my sweet tooth. And, as any chocoholic can attest, there's no end to the flavours you can pair with chocolate. A long-time favourite combination is milk chocolate and peanuts. The savoury contrast of peanuts is the perfect foil to the sweetness of the chocolate. Nice. This bar features a thick layer of milk chocolate around a sweet, salty and crunchy peanut butter candy centre. But making that peanut butter candy centre is the tricky part. The process begins by combining liquid sugar, corn syrup, coconut oil and molasses. They mix and heat these ingredients for 8 minutes. They then pour the cooked candy into a large bowl. Next, they add the leftovers that didn't get used in the previous production run of candy chocolate bars. They call these leftovers rework because they rework them into this new batch. Once the rework has softened up and been mixed in with the hot new candy, they empty the bowl onto a cold stainless steel table. They blend the candy until the rework gradually melts and the two merge into one sweet gooey mass. Once the candy has cooled slightly, it's folded up and carried over to the pulling station. Here, they make a pocket in the centre and fill it with vanilla extract. It's then time for the pulling machine to do its thing. The machine repeatedly stretches the candy non-stop for 5 minutes. This infuses the candy with air so that its consistency is soft rather than hard. They then transfer the candy to a belt that transports it to the weaving machine, which will weave in the peanut butter. The machine's roller first flattens the candy into a thin sheet. Then a pump draws piping hot peanut butter from this tank and deposits it in a layer onto the candy sheet. The sheet is then rolled up. When the roll reaches a specific diameter, they fold it and place it on a blank sheet, meaning a sheet without peanut butter on it. The next roller presses the folded roll flat onto the blank sheet. Then they roll up the blank sheet, sealing the peanut butter candy inside. This complex assembly is what forms the flaky layers in the chocolate bar centre. The whole mixture is then rounded out between two rollers and fed to the rope sizer, a machine that stretches the peanut butter candy into a rope so that it's the exact diameter of the centre of the chocolate bar. The next machine makes a pinch mark every 12.5 centimetres, the length of the chocolate bar. The linked centres then enter a cooling tunnel set to 7 degrees Celsius, and they exit 5 minutes later, rigid. As they drop to the next conveyor belt, they separate. They then pass through a second refrigerated tunnel, which finishes cooling them. The centres move into lanes that feed the enrober, the machine that will coat them with chocolate. Eagle-eyed watchers make sure that the centres proceed in single file and are properly spaced. The centres pass through a hot rinse of milk chocolate. Then, an overhead dryer blows off the excess, leaving a layer of chocolate that's consistently 3 millimeters thick. The bars enter a final cooling tunnel to harden the chocolate. The finished chocolate peanut butter bars are transferred to a conveyor belt that lines them up for packaging. As the bars approach the wrapping machine, the in-feeder arranges them in single file. Rolls of printed plastic film unwind into the machine's forming box, which quickly folds, wraps, and heat seals the film around each passing bar. A revolving knife slices the wrapper between the bars. It's then off to the packaging department, where they're packed 24 to a box. And now these bad boys look good enough to eat. The question is, why are there only 24 in a box? Mind you, I could just get another box.